Good afternoon, everybody. I'd like to give you some presentation, introduction about the work we did related to community-based air quality study. It has both outdoor and indoor components. I want to tell you, how we walk through those processes. Why is same monitor can be used for different kind of scenarios. Next slide, please. Yeah, I'm from medical school, the Health Science Center. So I'm an assistant professor in internal medicine at the Division of Epidemiology, Biostatistics, and Preventive Medicine. So every time I talk about a fire, smoke, I like to bring this image up. So this is the image that our colleague at the Earth Data Analysis Center made for us. It's an image taken on May 14, 2022 from a Lancet satellite image to show you how bad the fire was, in that specific location. So it burns. I don't want to go into too much detail because there are a lot of parameters. How you look at the smoke, different color indicate different thing. But the point is, Morgan County, which contains like 90% of residents in Morgan County are Spanish descendants or Hispanics. And in this area, east area of this mountain, there's no air monitor at all. So we don't have a lot of data to show how high the air pollution is during that period of time. But there are three major cities in New Mexico, Tulsa, Santa Fe, and Albuquerque. You can see the levels, how high it is. So March and July are the non-burning time prior to the fire and post the fire. But during the fire, you can see even those cities are far away from those burning sites. Also, they are not at dormant site. There's still you see spikes of the particulate matter 2.5. For Albuquerque, it increased about from 5 to 10. From other cities, you could calculate the ratio because their background is low. It's even higher. So another thing I want to tell you is the new EPA annual ambient level, PM 2.0 level is 9, so which is where that line sits. So clearly there's many days during that fire we have levels exceeding the EPA levels, but those are not counted as not in compliance because there's a reason for that. Okay, next slide please. So we did a little bit of study using the in Albuquerque. So we have a cohort, it's called Avid Smoker cohort. So we want to see whether this fire leads to anything or not. And those are the measurements on the next slides. Not yet. We would show you what health measures we use for this study. But from 2006 to 2016, so we have about 381 smoke days. So basically, those are the number of days that Albuquerque overlap with smoke plume you can get from NASA satellite. So I'm sure it's about 40 days per year, but I'm sure you don't recognize that, right? So you probably only know when the sky turns to purple, there's something going on. But actually, there's a lot more days that you're exposed, you breathe smoke, but you don't recognize it. Okay. So most of the time, those are each smoke, but if you want to look at number-wise, remember the annual level is 5 microgram per cubic meter, but those smoke contribute on the days that we have smoke. The smoke added 2.3 microgram per cubic meter, so it adds a lot. It's about 50% addition to the baseline level. Next slide, please. So we have some health measures. It really looks like those smoke has some acute effect on the psychometric measures in terms of, for example, how you feel today. Do you feel more anxious? Is your lung health bothering you more or less? Those type of things. Next question. Next slide. So the point is, this is the same information but presented in a different way. But there's additional information. This is where the fire was going on in Albuquerque. Okay, the fire from the Kelf Canyon hermits and how much air pollution it has to affect the Albuquerque. But look at those. This is in the winter time. Okay, you see another peak. So where are those Those are from residential wood burning, from the houses that burn wood for winter heating. Okay, and you see that at Tulsa as well, but not in Santa Fe. Probably they have really, because of the economic situation, they just use gas furnace, so things like that. So we have a study funded to study how much indoor wood burning affect indoor air quality, as well as what kind of health outcome, whether we can find some health measures that are affected by this indoor wood burning. So we conducted a panel study design. So we have shoulder heating, which means they just start to heat their house in the winter time. And then peak heating, January, February, which they heat the house a lot, right? That's the peak heating time. Next slide, please. It's a multi-site study. Not in Mexico. We also have people from Montana, Boise, Idaho, as well as Alaska. Next slide, please. So we use this TSI Blue Sky 8143. This one is our only measure, particular matter, like a PM1, PM2.5, PM4, PM10. I just learned PM10 is awful, right? Not trustful. Yeah, there's not much airflow. Okay, very small fine inside. You can barely hear it. So this is a typical pattern of indoor PM2.5 level, how it fluctuated across time. So on the right side, of this slide, you see how the PM2.5 level goes up really high and then gradually goes down. So the issue for this is we learned later on is those peaks are not just biomass burning. Think about it, when you get home, it's cold, right? You put wood in, but what else do? You start to cook, right? And when people burn wood for heating, they like to boil a pot of water on it. And this water, the water we drink, it's not pure. It has something in it. Those impurity get released into the air as well. So there's a bunch of other stuff there as well. So that's why those PM2.5 monitors, they really don't tell you what's in it, what they are really measuring. Next slide, please. Okay, so I want to go a little bit faster. The major finding from this study is we do see that during the peak heating, their burning time doubled compared to shoulder, which they just start to regulate the burn, right? This is very easy to understand. But for PM2.5, I really don't expect this results, okay? If we just do an average, so peak heating has the same level as shoulder heating. So you burn really hard versus you don't burn that hard, the indoor air pollution doesn't change much. But if you specifically split them into morning and evening, during evening time, no difference. But during morning time, there's a difference. The peak is higher than shoulder because when it's very cold, people will light up their stove in the morning. That's it. Okay, next slide. And we did a very, this is actually the assay we did in the sputum sample. So those combustion particle, one important composition in the combustion particle is called black carbon. It's incomplete combustion of the wood. The size is very small. It's about 100 nanometer. So, but under the microscope, we can see some black dots. Those black carbon looks black under the bright field microscope. So that's how it looks. Okay, if you see that on the right corner, so the black dots, they are black carbon. And from the New Mexico, we also have this summertime. We also collect this sputum sample from summer from the same household that burn wood for winter heating. We also collect sputum sample in the household who burn gas. We use gas furnace for winter heating, and you can tell that level increased by 3-fold. We have updated results by adding more samples in the winter time. The carbon load in the sputum sample, in the sputum macrophages, increased by 3 to 4 folds. But this doesn't seem very consistent with PM2.5, right? Because PM2.5, you really don't know what PM2.5 is really measuring in a specific household. It's not just combustion particle, it has a bunch of other exercises. Okay, so I want you to pay attention that the distribution, okay, the size of the diameter of the particle engulfing the macrophages peaked around 300 to 400 nanometer. This is the one. It peaked around here. You don't see smaller sizes. You don't see over 1 micrometer. So people talk about PM2.5. It's that it's small, going into the deep ground, have a longer retention time. But actually, what's really in your macrophages? We don't see large particles. Okay, there's a multiple explanation for that. Next slide, please. Okay, we do find that people with long comorbidity that turns to have more symptoms during the winter peak versus shoulder. Next slide, please. Okay, so we really like to figure out what size of the particle that's still released. So we did this study. So we take this machine, it's called Malta, into the different households that burn wood for winter heating. Next slide. So the sizes is really, the top 3 are typical size distribution. So it's all peaked around 100 nanometer. But if you look at lower side, those stir fry during when we were measuring those particle sizes, some people will warm up a bowl of noodles on the stove, and on the left side, lower left side, people are boiling water on the stove. On the right side, they turn on the gas stove to just eat a pizza. So the pattern completely is gone, okay, because of that. So then now you understand in the indoor air pollution study, there's tons of particles not coming from the burning, but from other things. Okay, so the point is this. The point is, in the indoor wood burning situation, to directly release this particle are small, 100 nanometer. But what we see in the lung are larger particles. Where do those larger particles come from? So this is really the setting. The point that I want to make is, for indoor wood burning, 99.9% particle goes outside. Okay, when they get into the outside ambient, there's some reaction happening. Called secondary reaction, or sometimes the particles also attach to each other, then they infiltrate back to your house. So that's how you see those larger particles in your lung. Okay, so when that study was done, I end up with tons of many air monitors. I told the other 3 said, send me your monitors. So I have like 1,500 monitors sitting in my lab. So I reached out to the Warren County commissioner and talked to her. So it looks like the people living in that community does have some concerns about this wildfire smoke. But that's already, my talk to her is in 2023. It's already after that fire. And also they're concerned about wind blow ashes. So we just start this program to put monitors at different locations. Those monitors need Wi-Fi, almost all. Okay? Need Wi-Fi, but also need electricity. But it can be used for both outdoor and indoor. So we attach them to those fire stations. This fire station has Wi-Fi, has electricity. Also, we attach one outside the sheriff office building, and there's another one we attach to New Mexico Highlands University. So those monitors worked pretty well, and so far we don't see some highly abnormal situation. The reason is because there's no burning in that area anymore in the past year. Next slide. So what we are trying to do based on this is, one is we really don't think just knowing particular matter is enough. We like to have a more expensive monitor installed that will measure those toxic gases like ozone, okay, CO2, ozone. Also, we like to install some black carbon monitors for both indoor and outdoor in that neighborhood. Second is, those monitors are so dependent on the Wi-Fi and the electricity. So you really have, if Morrow County doesn't have that capacity building or fire station, you probably really have a hard time to find a house to attach that. So but in some situation when there's a wildfire burning, it's probably in the mountains. So we would like to also add the solar and cellular capacity into some of our monitors so it can be dispatched independently, but also treated as an emergency response. If something happening, we can just bring those sets to the location. Another important thing is we talk about air pollution, but actually, if you just use one or without knowing what's going on, you get an average in that community, right? But we really like to find those hotspots. For example, there's multiple houses, built in the valley, and everybody burn wood for winter heating, then the air pollution in that area will be much higher compared to the other area. So we would like to do some research on that to see the map and see the location of the houses, and we'd like to put monitors, outdoor monitors, into this smaller, much smaller community, and combine with this indoor monitor as well as black carbon. I want to have more understanding. So eventually, next slide. I think that's it. Yeah. So eventually, I think it's the balance between we serve the community versus how to get grant funded, address a scientific question. It can further feed back to the service in the community. That's the point I want to make. Thank you.